weir is a structure that they put 25 of these rock structures in the stream for restoration purposes. And so some background on that. These were installed in the upper Cache River to help prevent the lowering of the stream channel, because that lowering is threatening the drainage of the pond, or the parent pond. So I was curious about just the weirs and how they all worked, and do people follow up? Are they doing what they're supposed to be doing? Those were some of the questions I had initially. I did find out in my literature review that the channel continues to lower. Since 1996, they've lost 2 feet. That doesn't mean the weirs aren't helping, but we don't even have any way to tell if they are, which is kind of interesting. The weirs also serve to direct erosion away from the pond, but again, the bank incision continues to happen. It helps reduce the stream power by stepping the stream down. So in my literature review, I found a lot of information about weirs. A lot of them were European studies. I also found a lot of local papers, because there's people at SIU that are doing a lot of work comparing weir and non-weir sites, in the Wiles lab especially. And there was a paper by Walter and Wiles that they were trying to see if they expected that the biodiversity would greatly increase in the stream when the weirs were installed. And they didn't really find that, which was curious to me. And then I saw other studies that were saying some of the same things. So I'm trying to design a study with these weirs and some of those ideas in mind. I decided to think about, is there really measurable habitat difference? Is it really, have the weirs really changed the habitat in the cache? So this is my question. Have the weirs installed in the upper cache increased habitat heterogeneity? And I am just talking about the physical habitat here. So there were 6 sites that I used. They're paired, weir and non-weir. And you can see on the map there where the sites are, the non-weir in the yellow and the weir in red. These are all sites that people at the Wiles Lab have been using for other research. So they're very studied sites from the biological perspective. And this is Eric and I out, and I'll get into the methods now. But at each site, we took a transect, and that's, you can see the tape. So we set this up, but actually that's not even the first step. The first step was to get to the site and look for snakes. And after you carefully clear the site of all poisonous, yes, snakes, then we start doing this. So we measured the stream in various ways. We measured the wetted width. We measured the depth every 1 meter along the transect. We measured the water velocity at 6/10 step along the transect, and there's pictures of the equipment, and there we are there. That's probably Eric out there. Yes, yes. This was interesting though, because even though they seem simple, the wetted width, we got out there. Where exactly does a stream start? We got the tape out there, and we're actually having little discussions about exactly where are we going. Where is the water exactly starting? So we had a lot of really interesting things happen there. We also looked at the substrate. And here's Connie. We reached down 100 times. Sometimes you could see it, and sometimes you couldn't. And took a sample and either measured it if it was a rock, or categorized what the substrate was as clay, silt, or sand. And science is messy, like she says her data is messy, but there's a lot of messy things around it. We also got out there and we were like, well, what exactly is clay? What exactly is silt? And then we had all these samples that were mixed. Well, how do you classify those things? So all of those things came up in the process. We also used the density. down. This was fascinating to me because it's like just so simple. It's like I was trying to figure out how we could make this in class, you know, PVC pipe and mirror and some levels are kind of fun. But we also looked at canopy cover to determine differences in habitat. So we took 10 random readings on each side of the bank, left and right. One reading at each 1 meter mark along the transect, and then 20 to 25 random in the stream. And again, things aren't perfect. You try to get out there and make it all perfect, but at some sites we got 20 random, and then we took 25 somewhere else. Yeah, someone's giggling. That's happening to somebody else too. And actually, the random on the bank side, there was one site that I got over to, took like 7 readings, and then I look over and I see the snake curled up, and I go, Eric, I'm out of here. 7's good enough. We also took dissolved oxygen readings, depth at every 1 meter along the transect. And there's some meters. One thing I like about this project that I can translate or I can take to my classroom is some powerful tools a meter stick can be scientifically. We got really important data just using a meter stick. And that's something I'll definitely do. The camera, that little densiometer, quite simple to use. This is just a lot. For you science people, read all that stuff, right? The teachers will go, you know. How we analyze the data. So this is the results slide, and it shows that our mean width at the non-Weir sites was 16.7 meters. The Weir 6.2. They were roughly 3 times the width, non-Weir versus Weir. The depth at Weir site 57 centimeters. The Weir's 11. It was really trickling, just like you guys saw. I mean, it just couldn't even. Like, is there really water flowing in here? So we have cross-sectional area, median substrate, mean discharge, mean average velocity, and then the canopy cover. As you can see, I did not have a lack of data for this. The dissolved oxygen, I'm not actually going to use. We just kind of took it for information. We did find that it was a lot higher at the Weir sites, but because we didn't do this at the same time of day, we didn't have a way to compare the same thing. So, again, we took measurements that we didn't necessarily use. The substrate particle size, this is kind of interesting because look at how different the Weir and the non-Weir sites are. Non-Weir had clay, silt, and sand. There wasn't a rock. In fact, why we had to go back to redo the one site is because there's clumps of this like dry clay in the bottom that we thought were rocks, and then we figured out no, they're not rocks, it was clay. So those were the only kinds of substrate at the non-Weir site, and then at the Weir sites we had large cobble, small cobble. Of course, they bring in all the rock at the Weirs. Canopy cover. It appears that even though you can see that at Weir sites it's more open than non-Weir sites, it didn't turn out to be statistically significant. However, it could be studied, I think, in the future if you just looked at the Weir sites from a disturbance point of view, the banks that were disturbed versus the ones that weren't. And then you might get something meaningful out of that. Okay, results. The water depth was significantly greater in non-Weir sites. There's a p-value for you. The wetted width was significantly greater in non-Weir sites. Cross-sectional area was significantly greater in non-Weir sites. The average water velocity was significantly greater at Weir sites. The median substrate was significantly greater at Weir sites. And there was no significant difference in discharge between non-Weirs and Weirs. However, that's, if you think about that, the discharge is amount of water going out of those kinds. It should be actually pretty close. So my conclusion is that the morphology and water velocity are significantly different between the Weir and non-Weir sites, so therefore the Weirs have added a new habitat to the system and increased habitat heterogeneity on the upper cache. Acknowledgements. I got lots. It's going to be like the Academy Awards, you know, the person you say like, it's going on and on. I got like 2 acknowledgement slides. I have no pride. Lots of people helped with this. That was what was really great. This project kind of, for me, it was very beneficial, and I remember once going to Disney World. It's not my favorite place, but they had this racetrack where you could rent the car, you know, and go out and drive really fast, and it like seemed real neat. Working with all the quality people from SIU, to me, I feel like I just did that scientifically. I had the best, great people helping me. I had the experience of being part of that process. So I thank you for that.